Alright, so chapter 4, part 4 is going to be on calculating concentration. First, we're going to focus on calculating molarity. So this example, the first example that we're going to do says calculate the molarity of a solution that was prepared by dissolving 11.5 grams of solid sodium hydroxide in enough water to make 1.50 liters of solution. Okay, so we're given a couple of different things in this problem, so let's write out what we're given. So we're given the mass of our sodium hydroxide is 11.5 grams, and the solution volume is 1.50 liters. Alright, so we know we're given mass and solution volume, but remember the formula for molarity, which is capital M, is moles of solute over liters of solution. Okay, and I'm just abbreviating solution there. So we need to get moles of solute. And our solute here is the solid sodium hydroxide, and our solvent is water. So first, we need to convert the grams of sodium hydroxide to moles of sodium hydroxide. So we do that by using molar mass. So now we need to calculate molar mass. So now you guys can probably already tell how much chemistry builds on itself. So we've practiced on how to calculate molar mass, and now we're going to use molar mass to convert to moles in order to find concentration of a solution. So all of these small skills really build up as we go through the semester. So keep that in mind as we progress. So the molar mass of sodium hydroxide, so we're going to find that by adding up the masses of all the different atoms. So sodium has an atomic mass of 22.99 grams per mole. Oxygen is 16.00 grams per mole. And hydrogen is 1.008 grams per mole. Okay, so we're just adding these together because we have one of each. So when we do the addition, get 39.998 grams per mole. Okay, so all sodium and oxygen both have 2 decimal places. So remember, we're adding, so our sig figs are based on decimal places. So we have 2 decimal places here, 2 decimal places here, and 3 decimal places for hydrogen. So our answer needs to have 2 decimal places. For right now, I'm just going to mark the 9 where the 2 decimal places would be. So I'm going to go ahead and keep all of the digits until we get to the point where we found our moles. Okay, so now we can use our molar mass to convert from grams to moles. So our mass of sodium hydroxide is 11.5 grams times there is 39.998 grams for every 1 mole of sodium hydroxide. And don't forget your sig figs there, so keep it marked. So if we do the math and divide, we get 0.28751,438 moles of NaOH. So now we need to look at our sig figs. So our 39.99 ends at that second 9, so that's 4 sig figs. 11.5 only has 3. So our final answer is going to have 3 significant figures. Okay, so in this case, there's a 5 beside the 7, so we're going to round up. So our answer is 0.288 moles of sodium hydroxide. Okay, so now that we have moles and volume of solution, we can calculate the molarity. So now we can do what we were trying to do in this problem. So molarity, remember, equals moles solute per liters of solution. So our moles of solute is 0.288 moles of sodium hydroxide, and we have 1.50 liters of solution. So now we just divide to get our answer, and our answer is 0.192 molar sodium hydroxide, and it's an aqueous solution. Okay, so that is how you would calculate molarity. So we'll go ahead and do a second example just to give you guys some more practice, and then once I have these videos up, there will be some practice problems on calculating concentration. Okay, so let me scroll down and write our next example. So this is example 2. So this example says calculate the molarity of a solution prepared by dissolving 1.56 grams of gaseous HCl in enough water to make a 26.8 milliliter solution. Okay, so again, let's look at what we were given. So that really tells you a lot about how you're going to solve the problem. So we're given the mass of HCl is 1.56 grams mass, and then we're given 26.8 milliliters as the volume. Okay, so remember our formula for molarity is moles of solute over liters of solution. Okay, so here we're going to need a couple of different things. So we need our moles of HCl, and then we need our volume in liters. So we need to convert from milliliters to liters. Okay, so step 1, we're going to find moles of HCl. So the molar mass is going to be the molar mass of chlorine, which is 35.45 grams per mole, plus the mass of hydrogen, which is 1.008 grams per mole. So if you add those two together, you get 36.458 grams per mole. Okay, 35.45 has 2 decimal places, 1.008 has 3. So we need to mark R5. So now we need to convert our mass to moles. So we have 1.56 grams of HCl times, there are 36.458 grams per every 1 mole of HCl. So remember, we need grams on the bottom because we have grams here and they need to be able to cancel. So that's going to leave us with moles. And when you do that math, you get 0.04278896 moles. And we need 1, 2, 3 sig figs here. We have 4 sig figs here. So our answer will be 3 sig figs. And remember, these zeros are leading, they don't count. So our answer is 0.0428, we round up, moles of HCl. Alright, so step 2, we need to convert volume to liters. So we were given 26.8 milliliters of solution. So remember, for every 1 liter, there are 1,000 milliliters. So if we divide 26.8 by 1,000, we get 0.0268 liters. And we're keeping the 3 sig figs because remember, this is an exact number. Okay, so now we have our moles of HCl, which is our solute, and our liters of solution. So now we can calculate our molarity. Let me get a little bit more room. So this is now going to be our last step. Calculate molarity. Okay, so write out the formula again. The more you write it, the easier it will be to remember. So moles of solute per liter of solution. So we have 0.0428 moles of our solute divided by 0.0268 liters of solution. When you do the math, you get 1.60 molar HCl. And again, this is aqueous because it's in water. Okay? So that is how you would calculate a concentration if you were calculating molarity.